Let's learn about the first topic in module 2, that is superposition theorem. The statement of superposition theorem is as shown here. A linear circuit means that the variables are linear in nature. The meaning of bilateral is that the main circuit properties does not change even if the voltage or current flows in either direction. So, superposition theorem states that if we have a linear and a bilateral circuit, the response in any element would be the sum of responses due to individual sources while the other sources are non-operative. So let's understand the meaning of this theorem. For example, consider the circuit which is given over here, and we have been asked to find the current I1 in the circuit using superposition principle. So we have two sources over here. One is a voltage source and the second one is a current source. So step 1, according to superposition theorem, let's consider the voltage source alone. We have to consider one source at a time. So let us consider the voltage source, and we will open circuit the current source since its internal resistance is infinity. Now using any method you can find the current I1 dash which flows through the resistance R2. So here we have been using mesh equation to find that current, and that is I1 dash is equal to V by R1 plus R2. In the second step, we consider that the other source is non-operative, that is voltage V is short circuited and the current source I alone is considered. Again, we can use any method to find out, like mesh, nodal analysis, etc. to find the current. So here the current I1 double dash is got using I R1 by R1 plus R2, that is the resistance of opposite branch by total branch into total current I. And in the step 3, we have to add the two responses. So this is the summary of superposition theorem. The first step, that is step A, we consider only one source at a time. We make the other sources unresponsive. That is, if we have a voltage source, we will short circuit it, that is draw a straight line, and if it is a current source, we will open circuit it. Open circuit means we will leave it open, so no current will flow through it. Next, step B, we will find the response of each of the source. That is the voltage drop or the current across the resistance according to the given question. And then step C, we add the two responses. So let's see how to do a simple problem using superposition theorem. So here there are two voltage sources and we consider each one at a time. So first let's consider the 50 volt source alone. The 25 volt source is shorted. Now using mesh current equation, we write that of mesh 1 and mesh 2. So on solving, we get the current I1 and I2. Now let's find the response through each of these resistors. The current through 5 ohm is I2, so it is 1.58 ampere, and in the same direction that we assume, that is left to right. Similarly, the current through the 10 ohm is I1, which is equal to 4.2 ampere. Since it's positive and it's in the same direction, we assume, that is it is left to right. Then current through 3 ohm is I1 minus I2. That is because I1 is greater than I2 and I1 and I2 are in the opposite direction. So the direction of the current will be that of I1 and the magnitude would be I1 minus I2. So for the ease of understanding, it can be written as a table as shown here. Next, consider a 25 volt source alone. So let's short circuit the 50 volt source. Now find the current I1 and I2 using mesh analysis method. But here we have to consider the current in the anti-clockwise direction since source is present in the right hand side alone. So once we find out I1 and I2, let's find the responses through each of the resistors. So through 10 ohm it is I2 and I2 is positive when we calculate it, so it is in the same direction that we assume, so it is from right to left. So it is 0.79 ampere. Similarly, we find out the other currents. The current through I3 is I1 is greater than I2 and they both are in the opposite direction. That is, I1 is flowing from top to bottom and I2 is flowing from bottom to top. So since they are in the opposite direction, we have to subtract it. So we will get 3.42 minus 0.79, so which is equal to 2.63 ampere. And the direction will be that of I1 since I1 is greater. So it is from top to bottom. Superposition theorem means we have to superimpose both the currents due to 50 volt as well as 25 volt. So we must draw a table for each of the resistor considering the 50 volt source, then the 25 volt source alone, and then we calculate the net effect. Since it is in the opposite direction, we subtract, and if it is in the same direction, we add. For example, consider 10 ohm. So here it is 4.2 ampere from left to right, and 25 volt it is from right to left 0.79 ampere. So we have to subtract both and the direction will be that of left to right since it is more. So it is 3.41 ampere. So similarly we will do that for all the resistors which is asked in the question. And for 3 ohm, both the direction of currents are in the same direction, that is from top to bottom, so we can add them. So the table here on the right actually shows the final answer, that is the current through each of the resistors using superposition theorem.